Hello, everyone. I'm Ross Brown from the Southwest Cyber Resilience Centre. I would like to welcome you all to the latest in a series of podcasts from the SWCRC. Don't worry if you haven't caught all the podcasts, i.e. Series 1, as you can access them via our website or on www.swcrc.co.uk or through Buzzsprout. This is Series 2, and if you and your business haven't joined the SWCRCs yet, don't forget our core membership is free and we provide you with National Cybersecurity Centre products to keep your business safer online. So you're very welcome. And today this podcast is led by Professor John Goodacre from the University of Manchester, who is here to tell us all about the UK Research Institute. John is Professor of Computer Architectures at the Department of Computer Science at the University of Manchester in the UK, having previously spent 17 years with Arm Limited as the Director of Technology and Systems, where he defined and introduced the first multi-core processors and other core technologies. He's also appointed by UK Government's Research and Innovation Agency as the Director of Digital Security by Design Challenge Fund, a £200 million programme to enable industry and researchers to create a step change in approach to cybersecurity, blocking vulnerabilities by design and protecting the operation and data by default. His research interests include web-scale servers, exascale efficient systems, and secure and ubiquitous computing. John, thank you very much for joining us this morning. You're really welcome.
Yeah, it's always interesting when you hear somebody read the bio you send. You go, oh, did I really say all that? But thank you very much. Good to be there today.
No, not at all. And thanks for the time that you're taking to speak to our listeners. So if I lead into it then to UKRI, the UK's National Cybersecurity Strategy realises that the unsustainable react and patch approach to cybersecurity today is not enough to shift the needle against cybercrime. So I guess we're always fighting to keep up, aren't we? Or fighting yesterday's battle, I think, probably.
Yeah, the words of fighting seem to be going endemic, don't they? In the fight against cybercrime, where what is it really? It's you've got a reliance on your digital systems, whether that's your phone or your home computer or the servers that you use or some web page you use to pay your taxes. Basically, the world's going digital and it's getting into more and more places. And those systems, unfortunately, are written in a way on a platform that is susceptible to the less saviour people of the world, finding that if there's some value there, I'll find a way into that system to extract that value or hold you to ransom for it. So, and NCSC is doing lots of graphs to show the number of vulnerabilities increasing, etc., etc., and you're getting the IT manager saying, "I can't keep up; it's not sustainable." So, yeah, the government sort of obviously, at 2016 did their first national cyber strategy, and it was very much about how do you protect yourself, what can you do to restrict the effects, how do you manage the risks, etc. And then there's a new version in 2022 that's well worth a read as well, because that's come up and sort of says, well, actually, the technology that we're using plays a part here. It shouldn't all be on the shoulders of the person that's running the system. So, let's stop trying to make billions of people, not click on things. Let's make it, if they do click on it, that it doesn't make a big issue. It's not a big challenge. And that's really, I think, the key part of the new strategy for me was that introduction of technology as part of the solution, not just the management of vulnerabilities.
Okay. Thanks, John. And it's interesting to sort of see it, I suppose, look at the problem from a very different angle. So can you tell us about the game-changing DSBD technology?
DSBD, isn't that a lovely acronym?
Yeah. And
I think I found something over in Australia that used it when I shortened it, but it stands for Digital Security by Design. It's a program name more than anything, but it's sort of fairly descriptive. And what it's really trying to say is, for the digital systems, which is the hardware side, is there a way that it can be designed but by default, but by design, can it protect you against the effects of vulnerabilities of your system? So if you think about it, today there's an inherent acceptance that there's vulnerabilities in your system. Yeah, you manage it, you try to reduce the impact, you manage the risks, you take out insurances, there's vulnerabilities. Because those vulnerabilities can enable exploitations, and only takes one hole in your system and the attacking could be in your system. What if the system itself by design said, okay, there could well be still some vulnerabilities because, you know, actually we're human and all that is human and there's going to be bugs in your system. What if the hardware itself by design could start blocking those vulnerabilities, stop them being as, you know, zero-day attacks, make sure that, you know, if there is an issue, the worst can happen is they might do a denial of service on you, but they're not in there stealing all your financial records and blocking up your system with with ransomware and things. So what the mind shift changes, and it's quite an interesting one to think, and I think your audience are probably all worrying about cybersecurity in terms of best practice, sustainability, patching regimes, all those kind of things, to think about how there's actually two other aspects that are coming through to the cybersecurity battle. There you go, I'll use the word. The first is one that's been dubbed secure by default, and this is where the people that are building your products are trying to reduce the attack surface, reduce the number of vulnerabilities that you're going to have to manage. And then the DSDB is the one stage beneath that, where we're actually, as I mentioned, trying to block the vulnerabilities from being exploited by the design of the system. So you sort of got this three level prong, so that the big bad world, if you like, doesn't have to, you know, keep chasing all these bugs in the system and managing them. We reduce the attack surface through by default configurations, by the way that designers build systems, but also the technologies that they use to build those systems have got features in them that can block vulnerabilities and stop, you know, fundamental classes of attack from actually even existing. You know, maybe I'll just take a moment. It's interesting because this problem that hardware or the computers inside systems allows vulnerabilities to be exploited was I found documentation from the American Department of Energy from 1970s. In 1972, in October, they published a catalogue of all the ways that the computer architecture does not protect software from exploitation, and it's still there today. And obviously, if you've had something for what's 50 odd years, then clearly something that's going to fix that is quite a game changer in terms of perceptions. Because how many people that are fighting vulnerability management today remember the 1970s when somebody said, "Oh, look, the hardware doesn't work," and what's happened and why the government's involved is that it was that 50 years has evolved a market failure. The businesses of the world can't actually change it or fix it. So we needed to convene and work with them to pull various aspects across the globe together to address this. So that's really the step change that's coming through the DSDB technology. It's some new hardware features that actually make a computer block vulnerabilities by design, while giving developers new tools to sort of reduce the blast zone should there be a vulnerability that's still remaining. It's not it's not going to solve every vulnerability, that's for sure, but it's, you know, researchers have shown that it's in the 70+% ballpark of ongoing vulnerabilities will just be blocked.
Because I know, speaking personally, the email system that we use blocks certain emails, for instance, that we don't know that are coming through. Is it a similar sort of technology, or is it far more reaching than that?
It's far more fundamental than that. So what you've got there is the idea of trust. Do I trust somebody to enter this system using that email? Because when the email enters the system, somebody might do something with it, or might do something to my system that's bad. So that's more of a trust restriction. I don't trust that. Whereas this technology is actually at the lowest level of the way a computer runs software. Okay, so I don't know how techie your guys are, but if we go all the way down to how a computer works, it's basically a set of instructions that says, move this value from this region of memory to this region of memory, maybe with some maths in between, and that's it. Now, the problem is the protections of the computer when you're doing those manipulations a fairly what's called coarse grain. You can really, if you break into this bit, you can go and touch that bit of memory over there, or modify that code over there and execute this bit of, overrun of a buffer here. So its trust is, if you like, the blocking of untrusted things. It still has the problem, if they get through that trust barrier, they can wreak havoc within your system. And, obviously people click on links. There was a great example where they used to use displaying a JPEG in a browser had a bug in it, which allowed them to then go and execute code that wasn't in the browser. They downloaded it, and obviously this technology would both stop that, but also, if there was another way of doing that, actually put the browser in a box that it couldn't get out of the image. So the worst it could do is corrupt the image on the screen. It couldn't actually go and start stealing your bank codes and monitoring your keyboard strokes, which obviously the other one could.
See, I'm guessing then the economic benefits are huge here, aren't they?
Yeah, and it comes across in multiple avenues as well, because to design or build and test systems today for the developer, they're having to use more and more effort, especially in anything that's high integrity. Your autonomous cars, the airplanes, your smart meter that might be turning off your heat pump in the future. Those kind of systems are taking huge amounts of effort to get by default have a lower bug problem in them as possible. Whereas this technology, it's actually making a lot of the kind of issues that they see when they develop, what we call hard errors. So in other words, oh, it doesn't work, let's fix it, as opposed to hidden errors that hide in the background that then can be exploited and found in the future. So there's a development productivity part of it. But I think the biggest advantage will be in the effort and the cost of the attacks and the management of remaining vulnerabilities. So that whole cost should come down. So, we're seeing that if what would have been a 0-day attack which left your system vulnerable and all your data ready to be downloaded, like I say, in best case, it's managed and it's just blocked and it doesn't affect your operation, or worst case, it's giving you downtime. But then at least you can schedule in your patching and your maintenance of the system to get rid of the fact that there was a fault in your system. It becomes a fault in the system as opposed to a cyber vulnerability in which you're losing data and losing your operational capability.
No, that's great. So I think we've probably covered a lot of these, but I would like to find out if there's any other expected benefits from bad DSBD that we maybe haven't covered yet.
Yeah, well, obviously there's a sort of a hidden, well, not hidden because we're actually actively promoting it, and I'll cover that hopefully a bit later, is that this technology or the approach was research done at Cambridge University here in the UK. The program was called Cherry. It had run about 10 years. They had then obviously interacted with another Cambridge company called Arm, which had looked at it and said, oh, well, that's quite good. Now, the reach of the fact that the core technology and one of the major routes to market is actually UK based has sort of encouraged the UK government to fund this as opposed to just leaving it for another 50 years. Yeah. But that obviously then gives businesses, particularly in the developer side, the ability to have early visibility of this step change. So obviously, in terms of benefit to those companies, they could say, well, actually, if I'm designing a product which is, has a 5-year roadmap, how does my roadmap benefit from the fact that there's this step change coming in what the computers, and they can get that visibility today. So, the program has a website called DS by Design, DSDB, by Design. I always get that wrong, but .tech. Obviously, I'm sure you can share that on some text underneath, but we have a program that's been run by the Digital Catapult, which allows small businesses particularly to come in and actually start looking at having early views of this technology, evaluate what it means to their roadmaps and things like that. So, large industries may have the 5-year roadmap. Small companies probably don't want to be blindsided. We've got other startups that have already looked at it and have said, well, actually, we're going to focus our business plan around that, because the VCs really like the size of this step change and the fact that you've got a year, 2 years advantage against about anybody else who hasn't yet had visibility of the technology. But it's obviously going global to be successful. But
sure. Can we have a very quick look at the resilience of current cyber practices and where DSDB really scores over what we're currently doing?
yeah, so resilience and integrity and safety are sort of words that don't always go together with the word security, because as you mentioned, security often is a trust thing today, and it's a risk management thing. So when you start looking at resiliency and the safety of a system and the integrity, the availability, and all those kind of aspects, we're talking about how can we keep the system running under, obviously, the cyber threat as well. So, for your phone, somebody attacks you, you turn it off and turn it back on again. It's that kind of resilience. You can't do that to a flying aeroplane or a control unit for the national grid or things like that. So resilience integrity has to come into as well. Now, clearly, if you are able to have a computer chip or a design of a processor which can actually tell you something's going wrong and allow you to build it in a way that it's constrained and restartable, you can start seeing how the resilience of systems can improve. So yes, people can do denial of service, and just basically hammer you with data and keep crashing you. But as long as they can't hold you to ransom or steal your financial data or take over your identity and all these things, that will obviously give the computers, people will have more trust in the systems. And I think, you might have mentioned it at the beginning, we try to look at what that aspect means to the social aspects of the technology as well. So the program we're on, the DSBD program, also has social scientists, and I'm sure there's socialists as well, but social scientists involved. So it's very much a whole community of researchers and business looking at the resilience, integrity, safety, the autonomy, the network communications, and the consumer and the servers and everything else. So it is very much a full ecosystem. If it's got a computer in, it hopefully will be affected by this step change.
And I suppose that's what makes it so different from anything that's come before, isn't it?
It is. So, people will sell you a magic tool that helps you manage your risk or give you a new filter on your email system. And it's sort of a point solution that you select to change. Because we're working at this very, very low level of how does a computer work, there's actually only a couple of ways in the world that computers work. There's a vast majority of devices today. Fix that and it explodes to absolutely every system that will be built in the future. That's the hope anyway. Obviously there's no commercial product available today. It is, if you like, doing the market validation and technology validation stage, but it's all looking pretty positive. So much so that Microsoft just a month ago actually announced that they had implemented one of their own microcontrollers. It's a RISC-V based processor. They've open sourced it, and that has this new technology in because of the new protection schemes. So, it is starting to filter into the system. The goal of the program and the structure of the program, the way that we've managed the essential IP, as it's called, is it's available for any architecture, for anyone who builds processors in the world. So it's fully open in that regard. So again, it's different. It's not a commercial product. It's a way computers work. And if we can change the way computers work globally, then hopefully in the future we'll be in a better place regards the protection of data and operation of computers.
Yeah, fantastic. That's really good news. I hope it's not a crass question, but how far off is this from people like our listeners being able to access this technology?
Yeah, it obviously is. The way that we started, or one of the major reasons the program started, was that if there wasn't a chip, nobody would write software for a chip that doesn't exist. Yeah. And if there isn't software, nobody will build a chip. Okay. So in essence, that's the problem that's existed for 50 years. Either there wasn't the commercial, I said this is fully open, it's to change the way computers work. Who makes money out of that? Pretty much nobody, actually, when you look at it. Security is not something a consumer buys a gateway product on. It's not even mentioned on Amazon and things like that. Security of the product. Yeah, but so there isn't a commercial model for it, but there is a chip now. So the ARM, we worked with a project led by ARM and Cambridge University and others that basically have built a leading processor for this evaluation. It's on a board. The program has, like as I mentioned, through the catapult, this mechanism for distributing those out to industries to have a look. So what that means is that the ecosystem and the readiness of the software is improving. In other words, we've got early versions of Linux. There's a couple of RTOSes. There's some programs happening in the commercial RTOS space as well. So it's sort of, oh yeah, everything seems to be working. Okay, we've got Java running now. Okay, this kind of thing. Oh, some of the managed languages of benefit. Oh, this new thing called Rust. Yes, it benefits as well because it still has this concept of, unsafe code, and the operating system isn't in Rust today. So Rust is benefiting both performance and security. The new features bring more capabilities. So there's an evolving of new ways of doing things as well. So, and there is an open source microcontroller. So if somebody wants to adopt that in a vertical integration and they are happy building their own SoC, they could start now. In terms of a end small company who wants to say, okay, I'm going to do a smart widget that goes and is deployed in the home, if all goes well, it's probably another 5 years just on the sheer time that it takes for something of this scale to morph through the very international semiconductor supply chain of creation and licensing and in manufacturing and readiness. So unfortunately, for the smaller companies, it's quite a while. For the bigger companies and the ones that say, well, you mean I can reduce my cyber threat risk from my business and my financial cost of maintenance? They're the guys that need to be talking to their suppliers and saying, hey, guy, I need this yesterday. How can I work with you to make this happen? So those guys, if they do it vertically, they can do it sooner. If they're waiting for a large company to move, then large companies need to be telling those large companies, hey guys, I've read about this technology, I've looked into the prototype, it's something that we need to help protect our business in the future and deliver the services. One of the government documents, there's a thing called the government cybersecurity strategy, not to be confused with the national cyber strategy, but it's about where the government digital estate's going. And they've made a fairly bold claim, is that they want their entire government digital estate to be resilient against known vulnerabilities and classes of error by 2030. Okay, so there are statements that large entities like governments and very large industries can make that would hopefully accelerate its adoption, but clearly, they need to look and understand the benefits of it, just like the businesses that have already looked at it.
And I suppose that makes sense, doesn't it? It's the sort of the early adopters, are going to pay more, and they're going to pay sooner because they get considerable amounts of benefit from it. Yeah. John, I'm really grateful for your time this morning. Are there any aspects of DBS-DB that I've missed that you feel we need to talk about? And if not, do you have any key messages that we can close down to our listeners?
Yeah, I think I gave my key messages just in my last little pitch, which is, if you're a small company wondering about where the technology is going, have a look, because the likelihood is you could get a time to market advantage by that visibility. If you're a software developer of any form that's either corporately working on open software, again, how will that software work in this new world is an interesting question. How do we build the ecosystem to a readiness that businesses, non-techie businesses can participate? And then for the larger businesses and the ones that have large investments in technology, hopefully, the plan is that this technology step change will happen. But when it happens and how fast it happens and how quickly businesses can benefit from it will be down to those businesses and their understanding and demanding and requirement of that technology. If you're working in a regulated business, what was the regulation for safety, integrity and safety and cyber look like? that's ignoring something as big as this step change, so those guys, and we're working with a number of them, but I'm sure there's other industries that we're not working with that really need to start to understand, okay, are we being negligent by not even understanding what this new computer technology can do for us?
That's great. Thank you very much indeed.
All right, well, thank you very much. Great chat.
So I think we'll leave it there, John. So out there to all the listeners, then, if you want to pick this up, you can get it through Buzzsprout. I'll put the link out on LinkedIn, so you can get that if you don't know how to get to it. Thanks very much for listening. And again, I'll put out the message that if you haven't already joined us as a core member, please take that opportunity. It's absolutely free, it doesn't cost you anything. And you can get us on www.swcrc.co.uk. And thanks very much for listening.